No it don't! No it don't!
So what I want to do with you today is I want to continue on with our lesson from last time, which is limits. Part 2. Now limits, really, you're going to spend at least 2 weeks on limits, so we got a lot of time on them. I've started with you a simple question last time of working with this lim. As x approaches 2, x squared minus 4 equals to blank. I want you to solve it. A, solve. And then B, I want you to write a statement about it. Like convert that into English. What does this really say in English? Write a statement. I'm going to give you some time to practice and try it out. So if you look at this question, there's many ways to think about this. I'm asking you, what is the limit as x approaches 2? Manat, what do you get? How do you get 0?
Because when you put 2.01, you get 0.04.
Okay. So let's say you're going to sub in 2.01 squared minus 4, and what do you get?
0.04.
0.04?
Yeah.
And let's say you sub in 1.9 squared minus 4, and what do you get? Negative 0.04. So I could say that it really approaches 0. That works fine. Nothing wrong with that. But if I look at this question, Karan, what did you do with yours? How do you?
I knew there wasn't anything to cancel out in the denominator, so I plugged in 2.
So one other way of saying, hey, what if I just plug in 2 right away? Because I said before, sometimes you can't plug in 2 right away, and that's if there's a restriction. But if I plug in 2 right away, look what happens. I go 2 squared minus 4. See, it works. It actually gives me a number. So either way, I get 0. You can either do option 1, works perfectly fine, or option 2, works perfectly fine. Nothing wrong with this. Annika, what's the statement for this?
Limit x approaches 2.
Yep.
Function
Limit as x approaches 2.
the function equals 0.
Is equal to 0. That's fine. Okay, is equal to 0. If I give you something a bit more challenging, like this, lim x approaches 1 of x minus 1 over x squared minus 1. Solve it. Go. Again, I'm going to pause it, let you have some time. I'm going to walk around. If you're lost in this stuff, hands up. Now in this one, if I sub in 1 directly, you notice something happens. So in this one, we may have to use another option. So I'm going to pause it. So in this question, if you look at this, you notice x cannot equal to 1. I can't sub in 1. If you sub in 1, your calculator says undefined. So we're going to choose a number really, really close to 1. And some of you say that's probably 1.0001 minus 1, 1.0001 squared. And no matter what you do, your answer should approach something called 0.5. That was my limit. That's easy. But the question is, does this always work? Does this always work? Because if it always works, my life is good. I don't need to think about anything hard. I'm going to give you one more question. We're going to find this out. Okay. It's going to say limit as x approaches 0 for cos, open bracket, pi over 0. Wow. Well, what do I do? What do I do? I'm going to pause it and let you have a crack at this. Each and every one of you, find the limit for me. Go. One boo-boo. It should be x here. Just a slight boo-boo. Just one tiny boo-boo. First thing, I'm going to give you a hint. Everyone's going to use a calculator. Your calculator works in two modes, degrees and radians. What mode should you be in and what gives it away? Radians. The moment you see pi, it's radians. Calculus only works in radians, never degrees. Degrees are done. Radians is actually a lot easier to work with. So I'm going to pause it. I want to hear some random numbers that you guys subbed in. Ali, what number did you sub in for x?
0.001.
X equals 0.001. And what if I use that for x, what's my limit?
1.
I hear limit of that cos pi of x equals to 1. Anyone else have a different limit by any chance? Wow. So therefore the answer is 1. We're done. No. Problem is this. You use 0.001. What if I were to tell you that I'm going to use a smaller number? If my smaller number matches 1, you're correct. If my smaller number doesn't equal to 1, something is wrong. I'm going to let you try this number now. I'm not sure if this works yet. This is going to be lucky. I've never done this before. 0.0001. What if I do something really smaller?
It doesn't equal, it goes error.
What would you get?
Mine works.
What did you get for your calculator?
Yeah, around 1.
If I do this, some calculators will have it should equal to roughly 1 still. But I'm going to ask you to do this. I'm going to pause it. I want you to do this now. What if I change numbers into something that's not easy for you guys to work with? X equals, use this number, 1 over 2001. What if I use that? Which is 1 over 2001. Punch in your calculator. 1 divided by 2001 gives you 0.00049975. Use that on your calculator. And if I do that, your limit as x approaches 0 for this cos pi over x, you would get -1. The problem now is, say, what's the right answer? If I use this tiny number, I get 1. If I use another tiny number, I get -1. So therefore, in this case, this is one of those odd ones. There is no limit for this one. There is no limit for this function. There's no limit for this function. See, now the question becomes, how do I know how small of a number should I use? Should I just use 0.00001? I use a small number and it gives me 1. I use another small number, it gives me -1. So really, how do I do this then if every number gives me 1? There's no for this function. So there has to be another method of finding limits. So that way there's guaranteed. I'm going to teach you method 2 of working with limits. Method 2. Because if I just sub in any random number, it works most of the time. But once in a while, there's going to be one of those twisted questions. We're going to break this down into 2 limits. This is what you've been doing this called. This is called the left-hand limit. Left-hand limit. I'm going to show you how it's written down. This is going to say lim. X approaches A. But now I'm going to add a little thing on top of A, this negative sign. This negative sign means left hand. So I'm going to circle or highlight this negative symbol. This means take the limit from the left. From the left. Okay. It means I'm going to use a number smaller than A. That's called the left-hand limit. This next is called the right-hand limit. Right-hand limit. Okay, so here's what I'm going to do. I go lim. As x approaches A, and notice there's a little plus sign now. This means take the limit from the right. From the right. F of x equals to L. So we're going to break your limit now into two limits, left limit and right limit. This is what you actually been doing before, except I didn't tell you what the trick was. And there's a clause that says this. Star. If lim x approaches a from the left of f of x equals to L, and lim x approaches a from the right f of x equals to L, then lim x approaches a equals of f of x equals to, if your left hand limit is L, your right hand limit is L, guess what your limit for a is? It's going to be L. Both sides must have the same limit in order for you to have a limit. If they don't, it's not going to be the same. I'm going to walk you through this because this is going to be tricky. Bubble this one. This is your second method of doing limits. Okay. It looks confusing if I just give you this formula, but in reality, all the saying is left limit equals to L, right limit equals to L, therefore A has to equal to L. I have a worksheet, semi-worksheet. I'm going to let you work together as a class because you need to use this worksheet. Every one of you should have a little sheet of paper that looks something like this. It's going to say compute. I'm going to walk you through slowly. This is going to be key. F of negative 4. Some say, Mr. What the heck is this? This is actually a piecewise function of two different curves. One curve goes like this. One curve goes like this. It's going to ask you, find f of negative 4. So what is f of negative 4 going to be? F of negative 4. See, f of negative 4 is right there. I'm going to let you play around with it. And then I want you to try B on your own, C, and then stop. So, okay, let's start. F of negative 4, it means find the value of y when x equals to negative 4. So, Nevros, what is y when x equals to negative 4? Nope. There's a boo-boo there. Undefined. See, here's the reason why. Take your little finger, go up to negative 4, and then go up. There's a little hole here. This little hole means there's nothing here. It doesn't exist. But some of you say, Mr. But it says right here. It means there's a gap at negative 4 too. Therefore, this one is D and E. Does not exist. Like your odds of getting an A in my class. D and E does not exist. Okay. Now, this is where my limits kick in. It says, find the limit as x approaches negative 4 from the left. There's a little negative sign. So here's how we're going to do this. As x approaches negative 4, it doesn't mean I go to negative 4 and I see what it is. I take my finger, start from the left, follow along. I go close, super close to negative 4 as much as I can. And guess where the number is going to hit? Imagine. It's going to be so close to 2. Even though there's no point there, we say that as x approaches from negative 4 from left, the answer is going to be 2. So let's write down a 2 here. I'm going to demonstrate that again. Say this means from the left. So I go left, up, 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 up. I get close to the negative 4 as possible, but I never touch. And as I get closer, closer, it will approach 2. Now it says, find the limit as x approaches negative 4 from the right. So now I take from the right side. Follow your graph along slowly. And notice one thing. It goes to 2 also. Because my left side limit is 2, right side limit is 2, you can go ahead and predict the limit x as x approaches negative 4. is also going to be 2. Even though it doesn't exist. But limit is not about choosing the point there. It's about getting so close to it as possible that we can say with confidence it's going to be that number. Try E, F, G, and H on your own. Yes, exact same thing. E, F, G, H. I'm going to pause it. So here we go. F of 1. Manveer, what do you have for F of 1? 4. Okay, let's see if you're correct. See, here's F of 1. Now somebody say, Mr. There's 2 points. Do you use the closed one or the open circle? This means there's nothing here. It is this. So I choose the one that's closed. Four. Now, I choose limit as x approaches 1 from the left. So take your finger. See, here's the point. I go from the left. It hits 4. And I just write down 4. I choose f of x approaches 1 from the right. See, now I start from this side. And I go use this curve. And now I follow along. Ruby, what should I end up with? -2. Interpol, so what's my limit? For the x approaches 1.
X approaches 1. Oh, no, I thought it didn't exist. Is there on both sides?
You're actually correct. D and E. See, go back to my notes. I was like, oh my god, Ashley got it right? Yeah, you did. See? Go back to my notes. A limit only exists. This is crucial. If x on the left equals x on the right. Hi.
Do not exist and no limit exists.
Potato, French fries. Okay? So there's no limit for that one. A limit only exists if your left and right hand limits are the same. If they're different, they don't exist. Now, some say, but Miss No, there's actually a point. Yeah, there's a point here, but that's not your limit. In this question, I have a limit and there's no point. Just because there's a point there, it doesn't mean you can have a limit. There's no guarantee. A limit is totally different from what the actual value is. Try I, J, K, L on your own. Go. And if you're lost, hands up. All right, guys, here we go. Way too loud. Settle down. F of 6. Guys, settle down. Pragya, F of 6. Go. 2. Correct. Praksha. Go. 5. Correct. Samandeep. K. 5 is correct. Joanne. L. Is it Joanne or 5? Joanna. Potato. 5. Height. Because why? Left side, right side are the same. Very easy. I'm going to give you your super no question right now. Good luck. Your team. Hang on. Shh. Before I give you your super no question, I got to teach you one more thing. What if I ask you, instead of giving graph, I give you an equation. Lim. X approaches 5. Positive. 6 over x minus 5. What's the answer to that? So instead of giving you a graph is really easy. Because I give you a graph and say, hey, this is fun. But what if I give you an equation this time? It asks you to find the limit as x approaches 5 from the right side. Because there's a little plus sign. Okay, choose an x from the right side. So be 6. So remember says, hey, let's lay x equals to 5.001 maybe. Because this means from the right. See? Right side. So this is going to be x minus, 5. So now I'm going to sub it in. 6 over 5.001. That's 6,000. So is my limit 6,000 then? Because if I use a smaller number, it's going to be like 60,000, then 6 million. So in reality, what is my limit then? Nope. It's the same amount I want to have in my bank account one day. You're actually correct. It's infinite. Because as it gets bigger and bigger, well, that's infinite. So that is a limit this is called infinite limit. So which means it goes on. Now, there's one more trick. There's going to be, go ahead, good question. What if I give you this? Lim. As x approaches 5 from the left of 6 over x minus 5.
It's the same thing.
Is it going to be negative infinity? See, notice left side and right side are not the same anymore. Therefore, there's no limit for it. This one, you can't have a limit. The one we just did in class yesterday. All the questions you just did in class yesterday. Nope. Okay. Here is your super no question, and this will take all the way until every one of you will have a different answer for this one. You can work forward. You can work, question is, can you work backward? It's going to say, sketch a graph that satisfies this. That satisfies this. So every one of you will have a different answer. Satisfies this condition. Lim. As x approaches 3 from the right, f of x equals to 4. Lim. As x approaches 3 from the left, f of x, that equals to 2. Lim. X approaches negative 2 of f of x equals to 2. F of 3 equals to 3. F of negative 2 equals to 1. In my previous questions, I give you a graph, you give me the answer. In this question, I give you the answer, you give me the graph. Show me how many of you can do this. Good luck, get together with your row. One answer. So you got to determine which person in your row has it right. There's actually 1,000 different answers. I'm going to pause it, let you have some fun. Work on that. Your homework will be your worksheet, and that wraps up your lesson for today. So